Hello friends, we are here now today to discuss about the talk on cold chain. This training program is being offered by the Cold Chain Logistic Resource Center at NIFTEM Kundli, and today we are going to discuss about the sustainable cold chain, how sustainable cold chain is. Cold chain portion of supply chain basically uses refrigerated conditions for transport, storage, and distribution of perishable commodities. Because perishable commodities, they need to be kept fresh and their shelf life should be higher so that they can be transported to the consumer in the best possible quality conditions, and also to ensure the food security, to minimize food wastage and enhance the farmer's income ultimately. However, cold chain technologies uses a large amount of energy which comes from the fossil fuels. Cold chain lowering the temperature requires lot of energy, and because use of lot amount of fossil fuels, it produces lot of greenhouse gases, and these gases are more polluting than the carbon dioxide themselves. So, transportation that uses diesel and petrol, they also emits harmful gases, all of which are damaging and destroying our climate. But the greenhouse's effect is more serious. There is inadequate data related to impact of cold chain on environment as of now, but it is estimated that total global cold chain infrastructure is responsible for 1% of the global CO2 emission. It is estimated that 10% of the perishable foods have access to cold chain, only 10%. On one hand, cold chain reduces the food waste, which reduces the carbon footprint. On the other hand, cold chain has significant impact on the climate. There are two ways in which cold chain causes the climate change. Firstly, by the direct emission of refrigerants into atmosphere, which have greenhouse effect, global warming potential, and ozone depletion potential. This is the direct effect of using cold chain. In second category, the indirect emission of greenhouse gases due to electric consumption, because all the cold chains, they are operated by electricity. So the emission of greenhouse gases using electricity, cold chain uses about 15% of total electricity that is generated worldwide. So you can understand this unit alone uses a big chunk of whole electricity. Now, what is ozone layer depletion? If I just give you an idea, ozone is oxygen layer located in the stratosphere of Earth's atmosphere. It protects the Earth from the harmful ultraviolet rays which comes from the sun. Researchers have found that our ozone layer is depleting due to emission of ozone depleting substances such as chlorofluorocarbons, halogens, and bromides, and these are the substances which are widely used in refrigeration and air conditioners. Recognizing consequences of the ozone layer depletion, United Nations adopted the Montreal Protocol to phase out the ozone depleting substances. They want it to phase out slowly from the uses so that they can protect the ozone layer. Greenhouse gases are responsible for global warming. These gases absorb the infrared radiations which are reflected from the earth. As the result, increase in the temperature of the earth. Refrigeration, cold chain systems uses electricity, huge amount of electricity which is produced by burning of fossil fuels. Burning of fossil fuels consequently emits the carbon dioxide which is responsible for global warming. Here we have some more information about the global warming potential. In addition to emission of carbon dioxide, refrigeration system emits other global warming potential gases such as refrigerants. Refrigerants today are often thousands of times more polluting than carbon dioxide. Refrigerants also releases into environment due to leakage in refrigeration system during filling, during repair and maintenance. Many a times air conditioners, freeze, cold chain, they are refilled. Gases are leaking, so those gases are ultimately going into the atmosphere. Here we have the list of refrigerant in this table. You can see that refrigerants like for example R11, R12, what is their ozone depletion potential? It's very high, 1, 0.82. Global warming potential, 4600, 10,600 and so. So these gases, they have very long atmospheric life. For example, R11 has a life of 45 years. It means once this gas goes into the atmosphere, it remains there for 45 years. So you can understand the impact of using refrigerant and how harmful or fatal it can be when it goes into the atmosphere and retain there for a period as long as 45 years or 100 years or so. Okay, there is another Montreal Protocol. Montreal Protocol is environmental agreement adopted in 1987 by United Nations member to regulate the production and consumption of ozone depleting substances such as chlorofluorocarbons, hydrofluorocarbons, halogens, methyl bromides and carbons, etc. So these are the ozone depleting substances, and this agreement is to regulate their use and reduce their emission in the atmosphere. CFCs have high global warming potentials which are used very commonly as refrigerant in cold chain. Since the adoption of Montreal Protocol, significant recovery of ozone has taken place. But is that enough? That is the question. Okay, let us discuss another agreement which is called as Kigali Agreement. It is the amendment to Montreal Protocol to phase out the hydrofluorocarbons. Hydrofluorocarbons, commonly known as HFCs, are commonly used in refrigeration and air conditioning. It was adopted to replace the chlorofluorocarbons, which was ozone depleting substance. However, HFCs don't have the ozone layer but have high global warming potential. They are responsible for increasing the temperature of the globe. To protect the consequences of emission of HFCs, parties to the Montreal Protocol adopted resolution, that is Kigali's agreement, to achieve 80% of reduction of HFCs by 2047. Okay, so let us move on to the next slide, which is solutions for sustainable refrigeration system in cold chains. What are the possible solutions which are sustainable? Okay, so let us move on to the next slide, which is solutions for sustainable refrigeration system in cold chains. What are the possible solutions which are sustainable? So sustainable solutions for sustainable refrigeration system, an intergovernmental panel on climate change has recommended to limit the rise of global temperature below 1.5 degree compared to pre-industrial level for sustainable development and avoid the threat to life on Earth. Rising global temperature and increased economic conditions of the people worldwide has accelerated demand for refrigeration. Consequently, this can bring climate crisis if we don't follow the path of sustainable cold chain. So it is a must for us that we must follow the sustainable cold chain path. In this particular slide, you can see what is the energy consumption and energy saving potential in cold chain. Cold chain has different units and operations like pre-cooling, frozen, storage, transportation, etc. So in each category, what is the emission of CO2? For example, in pre-cooling, the emission of CO2 is 20 to 330,000 tons per year. Energy consumption 310 to 610 gigawatt per year. So you can understand these operations are highly energy intensive operations. So if we can make some saving, it will drastically reduce the global warming and ozone depletion effects. So if we can follow proper energy saving techniques, we can save up to 20 to 30% of the energy which is consumed in these operations. So further list can be seen from the table how in individual operation these energy can be saved. One such way to do it is zero energy cool chambers. Zero energy cool chambers are very good alternative for reducing the temperature of the product to a low temperature without using electricity. Zero energy chambers is immovable low temperature chambers constructed for short-term storage of fruits and vegetables, particularly at farm level. Low temperature storage is essential to enhance the shelf life of the harvested produce. It reduces microbial growth, maintains the quality, and reduces food losses as well. Only thing, it cannot be transported. It will be static at one place. Mechanical refrigerated storage are most efficient and effective. They can cool quickly, but capital and energy intensive. They are not very environmental friendly, whereas zero energy cool chamber is best alternative to mechanical refrigerated storage. These type of systems, chambers, have been developed by Indian Agricultural Research Institute, New Delhi. Some advantages of ZECC, that is zero energy cool chambers, are their power requirement is almost zero and very environmental friendly. They reduces wastage at farm, they increases farmers' income, and then they can protect products from distress sale. You don't have to sell it quickly, you can store them for some time and then you can sell it when their prices are good. Zero energy cool chambers are also very cost effective. They can be constructed with the local material which are available, such as bricks, sand, bamboo, etc. You can see here in this table for different commodities like mango, banana, sapota, how much increase can be obtained using ZECC. For example, mango, it can extend the shelf life up to 9 days, for banana 20 days, sapota 14 days, and so on. The weight loss will be very minimal, and they can be their quality can also be maintained in a very acceptable range. Okay, let us see what are energy efficient integrated pack house alternatives. Energy efficient pack house optimizes energy consumption and minimize the greenhouse gas emissions, which contributes to climate change. So you can see in this figure what are various techniques which can be used, various ways in which it can be made very energy efficient. So let me tell you one by one what are these things. It can use solar PV light to reduce electricity consumption and use of natural light, thus greenhouse gases emitted during the electricity generation can be reduces. It can be an indirect effect. Further, tall trees can be grown around the pack house and effective coating on the roof of building. This will reduce the refrigeration load in cold rooms. Moreover, cold rooms in the pack houses are well insulated and refrigeration is designed with advanced and latest technologies. In addition to this, energy efficient pack houses has features such as water harvesting and recycling windows for natural light, digital control units, etc., which can further save lot of energy. Solar energy based refrigeration systems are also there. Solar is the abundant free energy available to meet the energy demand of humans. Further, solar energy is non-exhaustible and environmental friendly. It doesn't contribute to emission of greenhouse gases, which are source of global warming. There are three methods through which solar energy is used in refrigeration and discussed below. One is the photovoltaic operated refrigeration system, solar mechanical refrigeration, and solar power thermal energy storage cold rooms. Let us see first photovoltaic operated refrigeration systems. In photovoltaic operated refrigeration systems, sunlight is directly converted into electricity using the semiconducting material, which is normally called as photovoltaic cell. Solar photovoltaic cell produces DC electric power, which is used for operation of DC motor coupled with compressors of vapor compression refrigeration system, which operates the complete refrigeration cycle. So it's the electricity generation and then use of solar energy. Solar mechanical refrigeration system, power required to run the compressor in refrigeration system is provided by Rankine cycle. In this system, sunlight is absorbed by solar collectors and this heat is used for heating of liquid for generating steam. This steam is then used to run the turbines to produce the mechanical power. Steam after the turbine run is condensed and reused. Mechanical power generated by turbine is used for running of compressors. Okay, let us see the next one, solar powered thermal energy storage cold rooms. In daytime, photovoltaic cells converts the sunlight into electricity which is used to run the vapor compression system. It can maintain temperature between 4 to 10 degrees centigrade. The speciality of this system is that it has phase changing material which stores the cold energy and dissipates during availability of solar energy, cloudy days and during night time. Water, hydrated salt, paraffin wax and water salt eutectic mixtures are the widely used phase changing materials. Various components are cold room, refrigeration system, solar photovoltaic systems, thermal energy storage system and batteries for auxiliary load. These are the important component of solar power thermal energy storage cold rooms. These cold rooms are insulated with PUF material. Solar photovoltaic system generates electricity power from the sun rays to operate some fans, etc., where electricity is required. Thermal energy storage systems provides cooling effect during the non-solar hours. Phase changing materials such as water, hydrated salt, paraffin wax, etc., they are used as a phase change material which can store the energy. Auxiliary power system consists of components such as solar photovoltaic system, inverter and chemical batteries. This system provides energy requirement of auxiliary electrical loads such as running of fans, of evaporator, temperature control units, lighting, data monitoring systems, and thermal energy storage control. What are the alternatives for clean energy? Alternatives for clean energy, particularly for transportation, are biofuels such as ethanol, methanol, biodiesels, and methane, etc. These are environmental friendly, and contribution to these to greenhouse gases is negligible by these biofuels. These fuels can be directly used or they can be blended with petrol and diesel. Further, clean energy sources such as hydrogen sources, natural gases, and solar energy can also be used for transportation. So you can see here in the figure, they are represented schematically, different biofuels, solar energy, etc. Now we can also use Internet of Things (IoTs) in cold chain to reduce the energy consumption and make it sustainable. Use of IoTs from the food production till the product it reaches to the consumer can significantly optimize the energy consumption. We have to very precisely use every step with the help of IoTs. They are used to enable sensors, particularly for temperature management, tracking of products, automation, and optimize of transportation. Further, they can provide real-time data which aids the quick decision-making process. Thus, IoT increases the efficiency of the operation in cold chain and reduces the energy consumption. So you can see in the figure, at every step, IoT can be useful tool to connect with the decision-making process, which can make the whole operation a sustainable one. Now, what are the ways we can develop National Cooling Action Plan? This can help the government to find out different pathways to sustainable cooling. India has formulated its Cooling Action Plan, which aims to reduce the cooling demand by 20 to 25% and reducing cooling energy requirement by 25 to 40% till the year 2037. Further, it plans to provide training to 1 lakh technicians serving in this sector. So, skilling these people will definitely help in achieving the target of reducing cooling load in the country by 2037. In conclusion, we can say cold chain for vaccines or food is very broad system consisting of several stakeholders and lot moving parts. For sustainable cold chain, there is a need of coordinated efforts from all the stakeholders such as farmers, industries, government, and logistic managers. Government through its policies need to invest in research for development of new and innovative technologies. Industries need adopt latest technologies and optimize the energy consumption. At global level, there is a need of proper implementation. Montreal Protocol and Kigali agreements. Further developed countries need to share technologies to developed countries. So in today's class, we have seen what are various gases which causes global warming, global temperature rise, and what are the sustainable ways in which these effects can be minimized and controlled, and how we can reduce the cooling load, that also we have seen. So thank you very much.